Good afternoon, ma'am. I am Gaurav Adhikari, roll number 19 of BTech CSC 4th semester. Today I am going to show my presentation on race conditions in JK flip-flop. Before we start our discussion on race condition, firstly we will see what is a flip-flop, and then we will see about JK flip-flop, and then we will go to the race condition. What is a flip-flop? In a very simple language, we can say that flip-flop is a type of sequential circuit where the present input is dependent on the past output. Now this past output is stored in a memory and that the memory is called a flip-flop. There are almost four types of flip-flop. The first one is SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. In this presentation we will see about JK flip-flop. JK flip-flop is the refined version of the SR flip-flop. It has the input following characters of the D flip-flop, but the two inputs are labeled as J and K. If J and K are different, then the output Q takes the value of J. I mean that when the J is high and K is low, then the output Q is also high, and when the J is low and K is high, then the output is also low. When both the input J and K are low, then there will be no change. But if J and K, both the inputs are high, then there will be an action called toggled, which means that the output will change back and forth from 0 to 1 or high to low from one state to another. It can perform a certain function of set and reset flip-flop, and it can also act as T flip-flop to accomplish toggling action if J and K are tied together. From all this we can conclude that J and K flip-flop is a versatile flip-flop. Here's a basic diagram of J and K flip-flop where we can see that there is two input J and K and a clock, and there is two output Q and Q bar. Now this is a simplified version of this J flip-flop where we can see that there is an SR flip-flop and the output is connected to the NAND gate of K flip-flop, and the output of another output is connected as the input of the J NAND gate. This is the truth table of JK flip-flop where we can see that if J is 0, when both are 0 there is no change. When J is 1, the output is 1. When J is 0, their output is 0, and both are high, then there is a toggle action. Then there are characteristics tables of J flip-flop which can be derived from the truth table, and excitation table which can be derived from the characteristics table. When the present state is 0, the next state is 0, and J and K is the 0 and don't care. And when the present state is 1, the next state is 0, then J is don't care and K is 1. Now coming to the main topic, that is race condition in flip-flop. The race condition occur when both the input of JK flip-flop are 1. If the width of the clock pulse T is too long, the state of the flip-flop will keep on changing from 0 to 1, 1 to 0, 0 to 1 and so on. At the end, the clock pulse is ascertained. This phenomena is called race around condition. Some people get confused between the toggling and the race around condition. Toggling is different because toggling is a control version but race control condition is not. Then this is the truth table of JK flip-flop where we can see that when the clock is 1, the J and K are both high, then the output are race condition. This is the clock timing where we can see that when the clock is high and J and K is also high, then the output is become race. This glitches coming is called race conditions. Now how to overcome this race condition? The first method is time delay method. The clock pulse of width t can be divided into two parts. Here we can see that the t is from this here to here. This is t time, and it can be divided into two parts. That is, one is high and one is low. So from the above slide we can see that circuit is operational only when the clock is high. The circuit is operational, and the circuit itself takes some time, that is known as the propagation delay of flip-flop, say T. Now this race condition occur only when this T is greater than T by 2, that is high time. Now if this T is less, that is if T by 2 high time is greater than the propagation delay of flip-flop, then the race condition will not occur. But this is not practically possible, so we will come to the next method, that is edge triggering. Before that, we will see what is triggering. Triggering means that making a circuit active. From the word making circuit active, I mean that if a being may I mean that making circuit active, allowing the circuit to take input and give output. There are two types of triggering. First is level triggering and second is edge triggering. Level triggering. In level triggering, the circuit will become active when the gate or when the clock pulse is at a particular level. The level is decided by the designer. We can see that this is the level triggering, where there is a particular level of the clock pulse. Edge triggering. In edge triggering, the circuit becomes active at negative or positive edge of the clock signal. I mean that here we can see that this is the high positive edge triggering, this is the negative edge triggering, positive edge triggering, negative edge triggering, and this is the level triggering. As we can see that the circuit is operational at level triggering, so at edge triggering the circuit doesn't have enough time to race, and hence the race condition will occur. Overcome. The next method and the important method is master slave method. The master slave flip flop is basically a combination of JK flip flop connected together in a series configuration. One act as a master latch and another act as a slave latch. The output from the master flip flop is connected to the input of the slave flip flop, and the output of the slave flip flop connected to the input of the master flip flop. We can see here that the output of the master flip flop is connected to the input of the slave flip flop, and the output of the slave flip flop is connected to the input of the master flip flop. There is one thing here to note is that the clock is connected to the master flip flop, but to the slave flip flop it is connected through a NOT gate. Let's see the working of the master flip flop. When the clock is low, that is 0, the master latch will become non-operational, but the NOT gate will convert it to the 1 high and the slave will be operational. Now at this time, the output will become generated at the slave flip flop, will go to the master flip flop, and when the clock is again high, the master latch will become operational and the slave latch will become 0 and non-operational, and the input will come from the slave latch and will go output to the as the output will go to the input of the slave latch, and again when the clock is low, the master will be non-operational and the slave will be operational. In this version, we can see that the timing of the clock pulse is that when the clock is positively edge triggered, then the master output master, that is QM, is high and the state is stored until the clock is negative edge triggered, when the clock is again high triggered, and as the output of the slave flip flop, the output is high when there is a negative edge triggered, and state will store until there is another negative positive edge triggered. So we can conclude from that when both J and K are high, then there is the condition become toggle and the glitches are removed, and hence the race condition is overcome. The master slave flip flop is also known as negative edge triggered because here we can see that the graph is same as the negative edge triggered. Thank you very much.